Guys, I'm slowly losing my sanity, so this is part 5 of our question paper solution. Let's begin, I guess. I don't know. For complete combustion, 1 mole of an organic compound requires 2.45 moles of oxygen. Which compound could be X? So we need complete combustion. So C2H5OH plus O2 is going to result in the formation of CO2 plus H2O. So let's see how to balance this. We are going to need at least 2 carbon dioxide. We are going to need at least 3 water molecules. So carbon is balanced, water is balanced. 2 into 2 is 4, plus 3 is 7. 7 by 2, O2. So this is not going to be the correct answer. So this is out, because 1 mole requires 3.5 moles over here. C2H2, once again, we are going to get O2, resulting in CO2 plus H2O. There are going to be 2 carbon atoms over here. 1 water molecule is enough. 2 into 2 is 4, plus 1 is 5. We are going to need 5 by 2 of O2. That is 2.5 moles, so this seems to be correct. Number 3, CH3CHO, once again, COH. If we burn it in oxygen, we are going to get CO2 plus H2O. Oops. Plus H2O. So there's going to be 2 carbon atoms required over here to balance this thing. I think I made a mistake in the last one. There was 22 4 plus 3 7. Yeah, I did make a mistake. So 7 means it only needs 6, so there's going to be 3 O2. So sorry for being an idiot, but J-hope. This one, 2 carbon atoms. How many hydrogen? 2 H2O. So there is going to be 2 into 2 4. 4 plus 2 6. 6 is going to mean 3 oxygen. So there's already an oxygen over here, so there's going to be 5 by 2 oxygen that is required over here. So 2.5 needed over here, 2.5 needed over here. The answer is going to be 2 and 3. So I forgot our scale. What was it supposed to be? Both 2 and 3 are correct. The answer should be C. In which pairs do both species have the same number of electrons? So let's count the number of electrons over here. 35Cl and 37Cl. Obviously, they are the same atom with the same atomic number. They're both uncharged, so they have the same number of electrons. So 1 is correct. Cl minus, if I bring out the periodic table, Cl minus gains an electron and has 18 electrons in Cl minus. And argon has 18 electrons by default, so 2 is definitely correct. K plus has 19 K is 19 electrons. When it loses an electron, it goes back to being 18. And argon by default has 18 electrons, so 3 is also correct. So the answer should be 1, 2, and 3. All 3 answers are correct. The answer is A. For 33, for which reaction does the value of del H5 represent both a standard enthalpy change of combustion and a standard enthalpy change of formation? So what is combustion? 1 mole of a substance is burnt in excess oxygen So completely in excess oxygen. So it has to be complete combustion. This is the formula for combustion. The condition is 1 mole of the substance has to be present. And for formation, 1 mole of a compound is formed from its elements. 1 mole of compound formed from its elements under standard conditions in their standard states. From its elements. So I'm just going to shorten things up a bit. So let's see. Carbon plus oxygen is carbon dioxide. Carbon is burnt in oxygen completely to produce CO2. This matches. And formation, elements are carbon and oxygen. They combine together to form carbon dioxide. 1 mole of the compound is formed. So this satisfies all our conditions. So this is correct. Number 2, 2 moles of carbon is burnt in excess oxygen to form 2 moles of carbon monoxide. Unfortunately, this is not complete combustion. So this is not combustion. Neither is it formation, because 1 mole of a compound is not formed. So it does not satisfy any of our conditions. As for carbon dioxide, this is not formed from its elements, so formation is not present. So the only answer available to us is 1. And if 1 is the only correct option, so it should be D. So yeah, this answer is going to be D. Number 33 is D. Okay. Moving forward, number 34. The temperature of a reversible gas phase reaction is increased. Which statements are always correct? More product is present at equilibrium. The average speed of the particles increases. There are more successful collisions per unit time. So the first one, the equilibrium position will shift depending on whether the forward reaction is exothermic or endothermic. So it changes, it is not constant. So this is obviously going to be wrong. The average speed of the particles is always going to increase if the temperatures increase as they gain more energy. So this is definitely correct. If the particles gain more energy, more particles are going to have activation energy and they're going to collide more frequently. So definitely the number of successful collisions is going to increase. So 3 is correct. If 2 and 3 both are correct, the answer should be, I think, C. So we have C over here. That is the correct answer. 3 samples of chlorine gas. Each contain 0.710 grams of chlorine. Each sample is reacted with a reagent. In the first sample, it is reacted completely with hydrogen gas. This one is going to take a lot of calculation, so bear with me. Chlorine gas, Cl2, is reacted with hydrogen gas, H2, to form HCl, HCl. This is a straightforward reaction. Chlorine plus hydrogen is 2HCl. Let's find out the amount of chlorine that is used. 35.5 into 2. This should be 0.01. 2HCl, 1:2 ratio. 1 mole of chlorine produces 2 moles of HCl. 1:2 ratio, so 0.01 into 2 is equal to 0.02. That is the amount of HCl that we should be getting. HCl has a mass of 1 plus 35.5, which is 36.5. So 0.02 into 36.5 is equal to, I believe, yes, 73 divided by 100 is 0.73. I should really have brought a calculator with me. Okay, so the first answer is correct. Number 2 is sodium hydroxide, cold. So we have chlorine gas with cold sodium hydroxide resulting in the formation of NaCl and NaClO along with water. That is how I remember it. I'm really sorry, but cold hydroxide is NaCl, NaClO. Warm hydroxide is NaCl, NaClO3. So cold sodium hydroxide, we get NaCl and NaClO. For this condition to match, it has, if we add 2 over here, this now has 2 sodium, 2 chlorine, 2 oxygen, and 2 hydrogen. Everything balances. So let's find out. Chlorine, 1 mole of chlorine is going to react with 2 moles of sodium hydroxide to produce 1 mole of sodium chloride. We already know the amount of chlorine used was 0.01. So the amount of sodium chloride will also be 0.01 into sodium is 23 and chlorine is 35.5. So 58.5 over here into 0.01 should be 0.585. So this is also correct. Next up, we have warm hydroxide, or hot hydroxide. So it is going to result in NaCl, NaClO3, which is Cl2 plus sodium hydroxide results in the formation of NaClO3. Whoops. Okay, spacing. I'm having a hard time with this. Sorry about that. Chlorine plus NaOH is NaCl plus NaClO3 plus H2O. I hope this equation is correct. So sodium hydroxide, sodium chloride. So we are going to need, there is going to be a bit of memorizing over here since this is a pretty complicated reaction. So I'm going to suggest you guys memorize this. Hopefully I get it right. There is supposed to be 2 over here and 3 over here, so we get 3, 2, 5. Did I mess something up? Really sorry. Cl2 plus NaOH. I'm going to cheat a bit because I cannot remember this equation at all, so I'm sorry about that. Okay, let's go. This is 3Cl2 plus 6 NaOH is 5 NaCl plus NaClO3 NaClO3 plus 3H2O. So this is what we are looking for over here. So we have 3 moles of chlorine. We already had 0.01 to begin with. Reacts with 6 moles of sodium hydroxide to produce 5 moles of sodium chloride. So the ratio of chlorine is to sodium hydroxide is 3:5. Cl2 is to sodium chloride, is 3:5. So we have 0.01 moles of chlorine. So we cross multiply 0.01 into 5 divided by 3. That should be what we get. So the answer will be 0.01 into 5 by 3 into 5 by 3 into whatever the mass of NaCl is. So we already know this is 58.5. So if I put it in my calculator, give me a second for my calculator to load up. So 0.01 into 5 by 3 into 58.5 is 0.975. So number 3 is also correct. So the answer should be A, since 1, 2, 3 all are correct. Number 36. Solid barium oxide is added to some ammonium sulfate solution in a test tube and the mixture is warmed. A piece of damp red litmus paper is held over the mouth of the test tube. Which observation should be made? So let's see what happens over here. So what we have is barium oxide, so BaO, plus ammonium sulfate, NH4 2SO4, reacting together to form barium sulfate, which is BaSO4, plus ammonia gas, NH3, plus H2O. This is the reaction that we have. So if I'm going to it's not important to balance. We don't have to balance anything over here. We just need to know what's going on. So if I hold a damp litmus paper, ammonia gas is formed, which is going to turn it blue. So this one's correct. Barium sulfate is insoluble white precipitate. So this one's correct. Brown gas is NO2, which is not evolved in this reaction at all. So this one is incorrect. The answer is going to be 1 and 2 only. So the answer should be B. Number 37. Which compound shows geometrical cis-trans isomerism? So we have CH3. So let's draw all of these compounds. We have C, double bond C, CH3, C2H5. So we have this. So let's just make it easier on ourselves. You don't have to just draw it exactly how they did. So C2H5, we have CH3 over here and an H group over here. So all this group and this group are different, this group and this group are different. As long as these are different, they are going to show cis-trans isomerism, so this is correct. If both groups in either one of the carbon atom is the same, for example, if this were our condition, hydrogen, hydrogen, CH3, C2H5, then this would not show cis-trans isomerism. So that is the premise that we are working on. Number 2, CH3, hydrogen, double bond CH, CH2, CH2, yada yada. So we have this two different groups over here, two different groups over here. This definitely shows cis-trans isomerism. For the last one, we have carbon-carbon double bond, C double bond C. There is C2H5 and a hydrogen over here. There is hydrogen and C2H5 over here. Two different groups, cis-trans isomerism is shown. The answer should be A. Number 38. Which pairs of compounds may be distinguished from each other by testing with alkaline aqueous iodine? So for alkaline aqueous iodine, our conditions are there needs to be an OH group and there needs to be an associated CH3 group. This thing is going to give us the iodine test, like it's going to be positive with the iodine. So what happens here is ethane 1,2-diol, carbon, carbon, OH, OH, hydrogen, 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 hydrogen. OH group is present, but no CH3 groups are present, so this is not going to give us a reaction. Whereas ethanol, carbon, carbon, OH, H, 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 H. So this is a CH3 group next to an OH group. Both conditions are met, so this is going to give us a positive test. So we can distinguish these two. Ethanol is going to give a positive test, whereas ethane 1,2-diol is not. So number 1 is going to be correct. For number 2, we can draw this again. Propan-2-ol. So there is carbon, 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 OH, CH3 on both sides. So CH3, CH3. So it follows our condition. Both conditions are met. Methyl propan-2-ol. This is methyl propan-2-ol. So we have OH over here, CH3 over here, carbon over here, H, H, H. But this is a tertiary alcohol. Tertiary alcohols are not going to be able to react with iodine to give the iodine test. So this one is not going to have a result. So this one is going to have a result, this one is not. So the two can be distinguished. So this is going to be a correct answer to us as well. For number 3, ethanol and butan-2-ol, we have ethanol CCOH. As usual, there is an H3 over here. Both conditions are met. This one provides a positive reaction. Butan-2-ol, 4 carbon atoms. There is an OH over here, a CH3 group over here. Both conditions are met. So this one produces a reaction as well. If both react with iodine, then we are not going to be able to distinguish these two. So this one is out. So 1 and 2 are the only ones that are correct. The answer should be B. For the last ones, if 1, 2, and 3 are correct, and the answer should be A, 1 and 2 correct B, 2 and 3 correct C, D correct 1. So the diagram shows an experimental setup which can be used in different experiments. Here we are using alumina or silica or baked clay. So this can be our reagent or our catalyst. We are using a liquid X which upon gentle heating is going to evaporate. It is volatile. It is going to pass through this aluminum. So if it is a catalyst, it is going to catalyze the reaction, and then the gas collected is going to be something. So let's see what happens. In the presence of aluminum, ethanol, when passed through aluminum catalyst under the conditions of heat, C2H5OH, dehydrates to form, sorry about this, under the effects of alumina, this dehydrates to form C2H4, which is gaseous. It is insoluble in water, so it can be collected in the trough over here in the by upward displacement method. So downward displacement of water. So this is going to be correct. We can do dehydration. As for oxidation of alcohol, this is not how we oxidize. The presence of alumina does not result in oxidation of alcohol. It results in the dehydration. So this is not something that we can achieve. As for paraffin, paraffin is a hydrocarbon. Upon heating, it is volatile. In the presence of alumina, large hydrocarbons are broken down into smaller hydrocarbons, an alkane and an alkene usually. So the smaller hydrocarbons can be volatile. So if they are gaseous, they are still going to be insoluble in water, so they can be collected by this method. So cracking is going to be possible with this setup. So the example of cracking that we can have is CnH2n plus 2 results in a smaller CXH2X plus CYH2Y plus 2. So X and Y are smaller numbers, obviously. So this is how cracking is going to be possible. So we can carry this out. 1 and 3 both are possible. So the answer should be C. All right, moving on. Oops, I didn't mean to save there. Number 40. The ester C2H5COOH COOCH2CH2CH3 can be made in a school or college laboratory by a sequence of 4 reactions or fewer using compound Z as the only organic material. So we are not allowed to use absolutely anything else. So let's find out what this product is first. So CH3, CH2, COO, CH2, CH2, CH3. That is what the product is. All right. So what can we do over here? This is an ester. So we are going to need 2 things. We are going to need propanoic acid for the propanoate part. And we are also going to need propanol for the alcohol part, for the propyl part. So this is propyl propanoate. So we are going to need both propanoic acid and propanol. So let's see how we can get propanoic acid and propanol from this. This is propanol. So by default, this is propanol. If we use an oxidizing agent, CH3, CH2, CH2OH in the presence of an oxidizing agent is going to result in a carboxylic acid, CH3, CH2, COOH. So we can get propanoic acid by oxidizing propanol. So both propanol and propanoic acid can be formed over here. Just propanol as a starting condition. So this is something that we can use to produce our final product. This is correct. This is propanol. So CH3, CH2, C double bond OH. If I oxidize it, we will get a carboxylic acid, CH3, CH2, COOH, propanoic acid. If I reduce it, we are going to get CH3, CH2, COH plus reducing agent is going to result in the formation of CH3, CH2, COHH. So propanol is formed, propanoic acid is formed. These 2 guys are going to react together to form this compound, propyl propanoate. So the answer 2 is going to be possible. For the last one, we have a ketone. So ketones can not be oxidized any further. So there is no way for me to get the acid that I want. And even if I reduce it, I'm only going to be getting OH, H. This is going to end up being a secondary alcohol, which is not going to be able to react to produce propyl propanoate. So this should not be our correct answer. So the answer should be 1 and 2. So the answer should be B. So hopefully this question paper solution was helpful to you guys. If it was, please do share it around. It is going to help me out a ton. And you could send the links for the YouTube channel to everyone in case you think this is going to help. I am going to try and upload every single question paper that I can get my hands on for both biology and chemistry. So looking forward to that. I'm also going to try and cover IGCAC and Edexcel I'm only human, so I don't know if I'm going to be able to cover all of them. If you guys need any help with any topic, let me know in the comment section, let me know in Messenger, wherever you want it. I'm going to try and help you out. See you in the next video. Peace.